Alright, so in this video we're basically going backwards. So instead of being given the parametric equations having to get the Cartesian, we have the Cartesian. Now we have to go and find the parametric. So essentially here you only need to use one of two things, either this expression or equation, so the Pythagorean identity, or the other version, which is the one that has tan and sec squared theta. Now the particular version of this that you want to use is the one that moves the tan squared theta to the other side. So you have sec squared theta subtract tan squared theta equals 1. Now what you can see here is that these two equations have a 1 on the right hand side and two squared things happening. Two squared things added, two squared things subtracted. So it's going to be really nice and simple to make them look, or to link up I suppose, with these. Now the other one here is a little bit different, doesn't have a 1 on the right side, but that is very easy to fix. So we're going to take the x squared plus y squared equals 9. Both of these equations have a 1 on the right side, so I'm going to divide both sides by 9. That's going to give me this. Okay, so now let's compare. Compare this to this. Can you see that you've got matching up parts? You've got the 1 on each one, you've got something squared here, and you've got something squared here. So it all matches up. It's really just the choices you make. Now generally if we're dealing with parametric equations, we tend to link the sign with the y, because that's historically the up and down, and the cos with the x. So what we're going to do here is we're going to say, okay, the sine squared theta part of this, one part, is going to be this. That is going to be that. So sine squared theta is equal to y squared on 9. Alright, what that means, if we take that even further, is that we've got sine squared theta equals y on 3 all squared. You see all I've done there is I've just taken the squared out. Okay, so it's now become y over 3 instead of over 9. And that means, let's take the square root of each side. We've got sine of theta equals y on 3. So therefore, I'll just move this a little bit over. So I might do this on at the top. Therefore, we've got 3 sine theta equals y. Now that is actually the first part of our parametric equation. The second part is the other part that we added. It's this one. So we've got this cos squared theta. I'm going to write down here now, cos squared theta is equal to, it has to be the other part over here, because we've got the 1 on each side. That makes it okay. So this is x squared on 9. So again we do the same thing, cos squared theta equals x on 3 all squared. So that means that cos of theta equals x on 3, and therefore 3 cos theta equals x. Now the two things that I've got there in boxes contribute to my parametric equation. So what I can say at the end here is my parametric equations are x equals 3 cos theta and y equals 3 sine theta. Now incidentally, you could have chosen any multiple of this as well. So what you could have done is here, in the format it's in, it's got a 9, you could have done this, bang, 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 and then just linked it up straight up. This is going to be the x squared part, this is going to be the y squared part, and that matches. And that'll give you something, it'll give you the same thing. So you can do it that way as well. Now there are actually many different parametric equations here that will give you the same Cartesian, but this is one example. Okay, now this one here, this is a very similar idea. It's very similar to the one that we just did. So absolutely have a go at B. I'd love you to have a go at that and compare it to the answer. This is on your homework sheet. See if you can get that. I'm just going to do C for you as a video, just because that's a little bit different and it uses this sec. So chuck this here. So again we've got the subtraction. I'm going to let this part be the tan squared. You can see that I've got the 1 on the right side, so that's all fine. And then I'm going to let this part here be the sec squared. So let's do that. So I'm going to equate, we've got sec squared theta equals x take 1 squared on 9, which means that sec squared theta equals x take 1 squared on 3 squared. So I'm just going to put all of that in a box. Take the square root of each side. Sec theta equals x take 1 on 3. 3 sec theta equals x take 1. Therefore, x equals 3 sec theta plus 1. So all you've done there is you've just gone backwards. Okay, and you've used this expression here, equating everything. Get the 1 on the right side. It just makes life much easier. Divide through to get that 1 on the right side. And again, we'll do it with the other one as well. So the one that's there in black, that's going to be the y. So we've got tan squared theta equals y plus 1 all squared on 4. Now just to shortcut it, I'm just going to put brackets around here and make that a 2. So it's the same. And we've then got, take the square root of each side, y plus 1 on 2. 2 tan theta equals y plus 1, and therefore y equals 2 tan theta take 1. And that is our other part of our parametric equation. So for this example, our parametric equations involve sec and tan because they link back to a parabola. So parametric equations are going to be, and you always want to list them, x equals 3 sec theta plus 1, y equals 2 tan theta take 1. And remember, have a go at that second example too, which is very similar to the first one, using sine and cos, just because it has the addition in the middle. So anytime you've got the addition, use this one. Anytime you've got the subtraction, use this one.